Today's topic is probability. We all know about probability definition, that is, probability of an event E is equal to number of favorable outcomes divided by total number of outcomes. For suppose while thrown a dice, number of all outcomes we get, that is 1 2 3 4 5 and 6. Out of 6 outcomes, my question is, what is the probability of getting even numbers? So that is, there are 3 even numbers, 2 4 6. The total number of favorable outcomes are 3 out of 6. Okay, so this is the definition of probability, the well-known topic. Now we have few formulas. So those are P of A union B equal to P of A plus P of B minus P of A intersection B. So this is the formula. Next, P of A bar, that is equal to 1 minus P of A. We all know that the minimum probability is 0, the maximum probability is 1. That is, so we are finding the probability of any event, the maximum probability is 1. Okay, so we have a few more formulas, those are not needed here. One formula, that is A and B are independent, then A intersection B, that equal to P of A into P of B. This is important. So if A and B are independent events, then probability of A intersection B equal to probability of A into probability of B. So now directly I am going to start with the question number 1. The question number 1 is, if A and B are two independent events with P of A equal to 0.6, P of B is 0.3, then P of A bar intersection B bar is equal to what? So we are going to find out P of A dash B dash. See, so the same formula, this above formula, that is P of A intersection B equal to P of A into P of B, is also applicable for the P of A bar intersection B bar. Now this is equal to P of A bar into P of B bar. Now that equal to 1 minus P of A into P of 1 minus P of B. P of A and P of B values are available. Now this will be 0.4 and this is 0.7, so that is 0.28 is correct answer. Now coming to the next question, the probability that at least one of the event A and B occurs is, what does that mean? At least one of those A and B means A union B occurs in 0.7 and they occur simultaneously with the probability is 0.2. That means P of A intersection B value is given 0.2. Then P of A dash plus P of B dash value we need to find out. P of A dash plus P of B dash. So this is also equal to 1 minus P of A plus 1 minus P of B. Anyway, we know the formula, P of A dash equal to 1 minus P of A. See, from these two, 2 minus of P of A, P of B. So we know that P of A and P of B formula, here I am taking P of A union B equal to P of A plus P of B minus P of A intersection B. This minus P of A intersection B is taken to the left side. Now P of A plus P of B will be P of A union B plus P P of A intersection B. That formula I'm going to apply here. Why? Because these two values are available. So 2 minus P of A union B plus P of A intersection B. So these two values are 0.7 plus 0.2, that is 0.9. So 2 minus 0.9 is equal to 1.1. Okay, so that is the answer. Now coming to the question number 3. So this is one of the important model. A man and his wife appear for an interview for two posts. The probability of an husband selection is 1/7 part, and that of the wife's selection is 1/5. The probability that only one of them will selection is, given information is, the probability of husband getting the post is 1/7. The probability of wife, so both wife and husband are applying for the job. So out of these two, husband get the job is 1/7, wife get the job is 1/5. So from this information we can write probability of husband not getting that job, that is definitely 6/7. That why? Because 1 minus 1/7, that is 6/7. Probability of wife not getting that job is 4/5. From these two information, I'm going to find out the probability that only one of them will be selection is. So that is so easy. While husband getting the job, wife doesn't get the job. That means only husband get the job. So while wife getting the job, husband doesn't get the job. Okay, so now I'm going to H bar. This is H bar. Now this value, that is 1/7 into 4/5. P of W bar is 4/5. Now P of W is 1/5. H bar, this is P of H bar is 6/7. So simplify this one. Denominator we have 35, numerator 4 plus 6, that is 10. Now 5 will cancel 2 times and 7 times. So please try to understand here. 7 5s 35, the 4 and 6 10. Now the value is 2/7. Now answer is 2/7. Okay, now coming to the question number 4. Right, A speak the truth in 70% cases, B in 80%. The probability that they will contradict each other. Okay, before that let me give another example question from the same given information, that is question number 3. Listen, all of you. Same question they may ask a method like at least one of those two get the job. To find out that value, at least one of those two get the job means, so total probability minus none of those two get the job, that gives at least one of those two means either husband get the job or wife get the job. We can solve in a simple way, that is 1 minus probability of husband not get the job and probability of wife not get the job. This result gives at least husband or wife get the job. So please make it note. They may ask the questions like this also. Okay, so now coming to the question number 4. A speak the truth in 70% cases and B is in 80%. The probability that they will contradict each other when describing a single event. Now the probability of A speaking the truth is 70%, at 0.7. Probability of B getting the job, B speaking the truth is 0.8. A doesn't speak the truth, that is 0.2. B doesn't speak the truth, that is 0.2. We know that. See, from this given information, what exactly is asking? The probability that they will contradict each other when describing a single event. So while A speaking the truth, this is what is asking. B doesn't speak the truth. They contradict each other. There is another possibility. While B is speaking the truth, A doesn't speak the truth. That means A lies. So this result gives contradict each other. That value 0.7 into 0.2 and 0.8 into 0.2. And this value is anyway okay. Is right? This somewhere missing here. This is 0.3. Please make it correct. This is 0.3. This one into this one, this one into this one. Here this is 3. Okay. Right. This is 0.24. Okay. Now answer is 38. 0.38. Not 38, 0.38. 38%. Now try to understand. Now coming to the question number 5, that is also in the same model. The probability that A can solve is 2/3. Probability of A can solve, same models, that is 2/3. Probability of B can solve the problem is, here the problem A can solve means A can solve the problem is, B can solve the problem, same problem is 3/4. Okay, if both attempted the problem, what is the probability that the problem gets solved? The problem gets solved. This is also the we can understand the problem gets solved at least by one of those two. Okay, that is what we need to understand. At least means total probability minus none of those two are going to solve. None of those two are going to solve. Now P doesn't solve the problem, probability is, that is 1/3. B doesn't solve the problem is the probability 1/4. Problem gets solved is also equal to one of those two. One of those two is going to solve the problem. So that means total probability. Okay, so these are the values of P of A bar, P of B bar. Now, so it is enough to find out total probability minus none of those two are solving the problem. So both are not solving the problem in the case of P of A dash into P of B dash. That this entire value is subtracting from the total probability gives at least one of those two are going to solve. So that gives the problems get solved. So that result is 1 minus 1/3 into 1/4, that is 12 minus 1, 11/12. So 11/12, option A. Now coming to the question number 6. So this is also a similar model. A probability that a person will hit the target in shooting practice is 0.3. Probability of hitting the target is 0.3. If he shoots 10 times, the probability that he hits the target is. So in place of 10, I am taking 2 times. So what happens, a person trying for the 2 times only, what is the probability of at least hitting the target? And at least one time, at least this is also equal to at least one time. The probability that he hits the target is also equal to at least one time he hit the target. Okay, what is the probability of not hitting the target is 0.7, that is 1 minus 0.3, that is 0.7, not hitting the target. So a person trying for the 2 times, what is the probability of not hitting the target? that is first time is not hitting the target and the next time is not hitting the target. So this result gives, so while trying for the 2 times, none of those 2 times not hitting the target, none of the 2 times hitting the target. So this result, that means ph dash whole square. So at least one time they are hitting the target means simply total probability minus none of those 2 times. So that result is 1 minus p of h dash whole square. So that 2 indicates, that square indicates the number of times he is trying to hit the target. For suppose in place of 2, if I am taking 10 times, simply that result will be, so 1 minus p of h dash whole power 10. Okay, so what is p of h dash? 0.7. This result equal to 1 minus 0.7 whole power 10. So this is an example for trying for the 2 times. He shoots 2 times, this is the result. If he shoots 10 times, this is the result. Okay, now next question number 7. Two dice are thrown. The probability that the sum of the numbers coming up on them is 9. If it is known that the number 5 always comes on the first die. This is the conditional probability. We can't take all number of outcomes while throwing 2 dice at a time. Actually, while throwing 2 dice at a time, total outcomes are 6 into 6. We all know that. Those are like 1 comma 1, 1 comma 2 and so on, 6 comma 6. Totally 36 outcomes we get. But all outcomes are not, no need to take here. The condition, the total outcomes are, which are, if it is known that the number 5 always occurs on the first die. So that total number of outcomes we have to consider only the first die shows 5, second die will be any one of 1 to 6. So these are the outcomes, total outcomes. Okay, so try to understand. So totally 6 outcomes. Out of these 6 outcomes is asking that sum of those 2 faces is 9. The sum of the numbers coming up on them is 9. So now where we are getting the favorable outcome, that is only 1. There is no other values that sum is 9. So out of 6 there is only one result that sum is 9. Now your answer is 1 by 6. Okay, now so coming to the question number 8. A and B toss a fair coin each simultaneously 50 times. The probability that both of them will not get tail at the same toss is. Okay, so here try to understand 50 times. Just leave that 50 times. I just want to know what are the outcomes while A and B are tossing a fair coin each simultaneously at least one time. So maybe the results are tail, 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 head, head, tail, head, head. Totally 4 outcomes we get. So while both A and B are tossing a fair coin each simultaneously, these are the result. Now the question is the probability that both of them will not get the tail at the same toss. Will not get the tail. This except this one, how many chances are there? So tail, head, head, tail, hedge, hedge. So that this result is not expecting. So what are the results here expecting? Any one of these 3. Now the answer is the probability of probability to get will not get tail at the same toss is simply 3 out of 4 times. This is all happen for the first case. Okay, A and B are tossed fair coin each simultaneously only one time. If they are doing for the second time, that happens for the same result. If they are doing for the third time, we get the same result. If they are doing for the 50 times, that gives the same. Okay, now that result is 3 by 4 whole power 50. Now your answer is okay. Now coming to the question number 9. A leap year selected at random, the chance that it will contain 53 Sundays is. So number of days in a leap year is 366. Out of 366, 364 is the number which is divisible by 7 in 52 days. That means definitely if the question is for the 52 Sundays, definitely your probability is 1. Anyway, out of 366, definitely 52 Sundays, 364 days only, 52 Sundays will be there. So to get 52 Sundays and the 364 days, the probability is 1. That is clear. So to get next Sunday, that means 53rd Sunday, that is depending on these last 2 days. What are those last 2 days? Maybe a chance of Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, another chance, Sunday and Monday. So these many chances. So how many are the 1, 2, 3, 4, 5, 6, 7? 7 chances. Out of these 7, we need only Sundays. That is this one and this one. So that probability of getting the last, 53rd Sunday is depending on these possibilities. So there are total possibilities are 7. The required one is 2. Now your answer is 2 by 7. This is for non-leap year. In place of 2, we get only 1 year. That means 365 days. That is 364 plus 1. That last day must be Monday, Tuesday, Wednesday, and so on up to Sunday. There is only one Sunday out of those 7 possibilities. Your answer should be 1 by 7. 1 by 7 for the non-leap year. So this is for 2 by 7 for the leap year. Now, so 10th question. 6 dice are thrown. The probability that different numbers will turn up is. So different numbers means what are the numbers we have in each die? 1, 2, 3, 4, 5, 6. Okay. So 6 dice are throwing. What are the total number of outcomes we get? For suppose while throwing the 2 dice, the number of outcomes are 6 into 6. While throwing these 3 dice, we get 6 into 6 into 6 and so on. In case of 6 dice are throwing, we get total number of outcomes are 6 power 6. What is the favorable outcomes we are expecting? While throwing 6 dice, the resultant outcomes should not be repeated. For suppose just to assume like this, there are 6 numbers are available. So how many ways we can arrange those 6 numbers to form 6-digit numbers which are not repeated? No repetition allowed. Okay. So for that, simply that is what is asking. 6 dice are thrown. The probability that the different numbers will turn up means, so we do arrange those 6 numbers in 6 different places in how many different ways without repetition? Simply 6 factorial ways. Now your answer is 6 factorial by 6 power 6. Now find out this result and simplify. you get the result one of those a b c d. Now try to find out this value. Anyway, you know how to find out the 6 factorial and how to find out the 6 power 6 value. Simplify, you get the answer. So that's it for today. So remaining questions I will prepare another video. So these are important, so try to solve these problems. Thank you.